Okay, hey, Math 20-2s. So what we're going to get into now is solving radical equations. All right, so here's an example. 5 square root of x is equal to 35. So what we're doing now instead, before we were simplifying, now we actually have an equals sign there. We're actually going to be able to figure out what x is. So the way we're going to do this is we want to get x on its own. That's the goal, right? So that square root symbol that's above this thing right now is going to be the last thing to go. The first thing that I'm looking at that needs to go is this 5 that's on the side of it. How we get rid of that is we always want to do the opposite of what's being done right now. And what I mean by that is right now 5 is being multiplied by the square root of x. So what we need to do is divide 5, and then whatever we do to one side of the equation, we have to do to the other. That's the only way we get away with doing anything, is if we do it to both sides. So now that we've divided both sides by 5, on the left side here I've got 5 divided by 5. Well, that's 1. So it's pretty much gone, right? It's just 1 out front of that, so that's the same as, so it's pretty much gone. And now what we have left is square root of x is equal to, and then 35 divided by 5, which is 7. Now we're close. We've almost got x on its own on the one side of the equation, but not quite. What we have to do is square both sides of this equation. And the reason why I'm going to square both sides is because if I square this square root, then they cancel each other out. The squared and the square root cancel each other out. And then what I'm left with on the left side of this equation is just x. And what I have on the right side is 7 squared, which is 49. Okay. The next thing that I'd like you guys to do, though, is called verifying. So what I mean by verifying is we're going to go back to the original equation. And we're going to see if we put this in, does it actually equal 35? Does the left side of this equation equal the right if we replace that x that we figured out with 49? So we're just going to keep moving down and say, okay, so the square root of 49 is 7. If I go down one more time, I got 5 times 7 is 35 and is equal to 35. Well, yeah, that's true. 35 is equal to 35. So that's how we're going to check our equations. All right, so moving on down. All right, so looking at this next one, it's going to be similar. We need to get x on its own. And now everything I see close to x here, it's all underneath the radical symbol, right? And it's a cube root this time. So what we have to do, we have to tackle this cube root first because it's kind of surrounding everything. It's kind of got everything else trapped inside. So that's got to go first. And the way we get rid of that is going to be by cubing both sides. Going to the power of 3 on both sides. And the reason why we're going to do this is because if I have to the power of 3 and then a cube root, they cancel each other out. So they totally, cancel each other. So what we have left on, if we do that, is going to be 4x over 5 is equal to 2 to the power of 3 is 8. So now we need to have x on its own, right? What I'm going to do is probably get rid of the 5 first. We could get rid of the 4 first. Doesn't matter in this case. But I'm going to get rid of the 5 first. So when you get rid of the 5, remember I said you want to do the opposite of what's being done. So right now we're dividing by 5. So what I'm going to do is multiply by 5. And to show multiplying by 5, I'm going to put the 5 up in the numerator. That's the same thing, right? So I'm like multiplying this term by 5. And the reason why I'm going to do that, so we'll do it to both sides because you have to. So multiply by 5, multiply by 5. The reason why I did that is because now 5 on top cancels with 5 on the bottom. And if I write what I have left here, I'm going to have 4x is equal to 8 times 5 is 40. Okay, last thing I'm going to do, divide by 4. Because I was multiplying by 4, I'm going to do the opposite. I'm going to divide both sides by 4. That 4 cancels with that 4. And I'm left with x is equal to 40 divided by 4. It's equal to 10. If we're going to check this, so if you check this, in place of, let's put that over there, in place of x, so x was over here, right? In place of that, I've put 10 just in its spot, right? So we're going to check this out to see if it works. So I've got 40 times 10. That's going to be, this will turn into 400 over 5 cube root is equal to, that's a huge 3, is equal to 2. This ends up being the cube root of 80 is equal to 2. Whoops. Sorry to confuse you guys. I knew that wasn't going to work out. That said 40 up there. It just said 4. So this should have been 40. My bad. So this shouldn't have been 80. It should have been 8. Okay, so cube root of 8 is equal to 2. And then the cube root of 8 is equal to 2. So 2 is equal to 2. Yes, it is. Sorry for the confusion there. Okay, so next one here. We've got the same situation. Everything's underneath the radical symbol. So what we have to do is get rid of that first. So we need to square both sides. So we square the left side, square the right side. The square cancels with the square root. And what we're left with is x plus 3 over 2 is equal to 4 squared is 16. All right, and this is where people get a little confused with algebra. They might make a mistake here. And we need to get x on its own. And there's two options. We can get rid of the 3 or we can get rid of the 2. And people might be tempted to take the 3, but we can't. We have to take the 2 first. And just to give you a little bit of a side lesson here of why, is the reason for that is because x plus 3 over 2, that's the same thing as saying x over 2 plus 3 over 2. Both x and 3 are over 2, so I can't, if I took the 3 first, then that's not right. I can't just get rid of that, right? Yeah, so that just doesn't work out that way. So what you want to do if you've got something over something like that, you're really picturing that they're in brackets. Remember your bedmass thing? We have to do inside those first. Like they're kind of like trapped inside the brackets. We need to get rid of that 2 first underneath on the bottom. So yeah, it's got to be the first to go. So we're going to multiply both sides by 2. So by 2 by 2, and then multiply this side by 2. So what we're left with is x plus 3 is equal to 32. And then the last thing is this 3 has to go. And like I said, we always want to do the opposite of what's being done. So right now we're adding 3 to both sides. So minus 3, minus 3. X is equal to 29. And we're going to want to check that. I'll just pause it and do it. And you can see I checked this, and it turns out that if I put 29 in place of x, then yeah, it does work out. 4 is equal to 4. All right, moving on to the next one. Oh, and that was C, I guess. D. Sorry, I got a cold if I sound funny. All right, so looking at this next one, again, the goal, remember, is to get x on its own. A couple of options that you might think at first. You might want to get rid of the -1. You might want to get rid of the radical. You might want to get rid of the 3. We got to get rid of the 3 first. You can kind of think about the 3 as just kind of being like tacked on to the side of this thing. It's like it's easy pickings, right? If you were going to get rid of something, that's the one that's easiest to go. So we're going to get rid of that first. And what we're going to do is the opposite of what's being done. So right now we're adding 3, so we're going to subtract 3 from both sides. That 3 cancels with that because that's 3, positive 3 minus 3 is 0, so it just disappears, right? It turns into 0, it's gone. So what we have left if we do that is the square root of x minus 1 is equal to 4 minus that 3 is 1. Next thing, I can't get rid of that -1 under there yet because it's trapped under the square root symbol. So I'm going to have to take the square of both sides. So I do that. Square cancels with the square root. I end up with x minus 1 is equal to 1 squared is still just 1. Last thing, get rid of this negative 1 or minus 1 I've got sitting there. I'm going to add 1 to both sides. So that negative 1 and positive 1 equals 0, so they're gone. I have to add 1 to that side. And I end up with x is equal to 2. So I want to check that. And when I do check it, when I put 2 in place of x and actually just do the calculation, I end up with 4 is equal to 4. So we're good. All right, last one. All right, here's our next equation. So we've got this whole mess up here. And again, what I'm seeing first off is that this negative 5 just looks like it's easy pickings. It's going to be good to just get rid of that first. So what I'm going to do is add 5 to both sides. And I'm doing that because negative 5 plus 5, that equals out to 0, so they're gone. And I'm going to write what I have left. And notice when I'm writing these, just make sure you guys do this too. Keep the equal sign constant all the way down and just keep writing what you have left as you go down. I always think that should be taken for granted, or you guys should just know that one, but maybe I shouldn't assume that. Yeah, so I'm going to write what I have left. We've got 2x plus 3 to the square root. Negative 7 plus 5, that's still negative 2. Okay, next thing I'm going to do is I got to take the square of it. I'm going to take the square of it. And the reason why I'm taking the square of it is because I got to get rid of that square root symbol. Everything's locked underneath there. So the square cancels with the square root, and I'm left with 2x plus 3 is equal to negative 2 squared. Well, that's the same thing as negative 2 times negative 2. Negative times a negative, that's equal to positive 4. Nope. I'll just put a little dot, dot, dot. Maybe like a thought bubble. Okay, so now we got two numbers that you might be thinking of, the 2 and the 3. We got to get rid of one of those. We need to get rid of the adding one first. Again, it's kind of like off on its own. It's not attached to the x. It's kind of easy pickings. Let's get rid of that first. We're going to say subtract 3 or minus 3. That cancels because they equal out to 0. And we have 2x is equal to 1. Last thing I'm going to do is divide by 2 because I'm going to do the opposite of what's being done right now. So divide by 2, divide by 2. I'm left with x is equal to 1/2. And now I'm going to check this. And I know the answer, so I'm going to check this without pausing it. So if I go back up to my original equation, I've got 2, and I was going to put in brackets where the x would be. I'll just put what I found this in there, right? So 2 times 1/2 plus 3, and it was the square root, and then it was minus 5 is equal to negative 7. Now I want to check, does the left side actually equal negative 7, just like the right side does? So if I simplify this a little more, I've got the square root. Well, 2 times 1/2, that's just equal to 2 over 2, which is equal to 1. Plus 3 minus 5 is equal to negative 7. If I keep going down, this is 4, square root of 4, minus 5 is equal to negative 7. This ends up being 2. Square root of 4 is 2. Minus 5 is equal to negative 7. This is saying that negative 3 is equal to negative 7. Huh. Negative 3 is not equal to negative 7, so something went wrong. Actually, nothing went wrong. This is why we check. This is why I want to make sure you guys know that this is why we actually do the green part I've been doing, is because if it doesn't work out, if you check and it doesn't work out, it's something called an extraneous root. Extraneous means it doesn't really apply here, which is true. And root just means solution. So this solution doesn't really apply here, is what extraneous root is really telling us. And it doesn't, so that we have to double check whether our solutions make sense or not. So I know this last green part kind of seems like a waste of time because you're like, well, I got it, whatever, I'm probably right. You need to check it to see if it actually exists or not. All right, that's all we're going to go through this class, so I'll see you guys in class tomorrow.